Hello everyone, welcome to another Quad Education Test Prep Fundamentals video. My name is Tom and today we're revisiting a math topic. The topic is exponents, and in our previous video we covered the basics and some of the interesting questions you can see for exponents, but today we're going to be getting into some of the trickier and more interesting topics that the SAT and ACT can throw at you for exponent questions. Alright, let's take a look. Okay, back to exponents. So in my previous video, I explained that I'm a really big fan of exponent questions because it's basically a little puzzle, and the same is true here. So just to review, we have our basic exponent equations there for you to see. I'll just run through them quickly so that we can just make sure that we have those in our common vocabulary as we look to these more interesting ones. For this video, we really have three main kinds of more interesting applications of exponent questions that we have to cover. And once we have all these understood, it's pretty much all you'll see for exponent questions in the test. So first we have exponent rules. We have x to the a times x to the b equals x to the a plus b. So power times power means we add. X to the a over x to the b equals x to the a minus b. So subtraction when we're dividing. X to the a to the power of b means we multiply. X to the a b. Next we have x to the a over b, so it's a fractional exponent. Fractional exponents are one of those things that give people the most trouble with exponents, so pay attention for this one. In this case, or in any case, for exponent fractions, the numerator is the power and the denominator is the root. So x to the a over b, b root x to the a. X to the a, negative exponent just means 1 over x to whatever that thing was. And then finally, x to the 0 is 1. So those are basic exponent rules. Let's take a look at the specific question types that you'll see for harder exponent questions. The first one here I'm calling large exponent cluster fractions. I don't know that this is actually what these are called, but that's what they look like to me. And these are characterized by this giant mess of letters and numbers raised to some power. And for the most part on the test where you'll see this, they'll raise it to a negative exponent just to make life more difficult. So if we're going to raise to a negative exponent with a fraction, we're going to flip this fraction. The first thing that we're going to do, in my opinion, that makes this easier is just to resolve everything inside of the fraction before we square it and flip it upside down. So let's go ahead and do that. So we have the top and the bottom here. We're saying, well, let's consolidate all of our x. So we have x squared divided by x to the negative 2. And that's going to give us power, divided by power means to subtract, so that's going to be x to the 4. Because 2 minus negative 2 is 4. We have y to the negative 3 there and y to the 5 on the bottom. So what we can go ahead and do is move this down there because y to the negative 3 is 1 over y to the 3, and 1 over y to the 3 times 1 over y to the 5 is going to be y to the 8th in the denominator. And then with z, I suppose we have z to the 3rd here, and then z to the 4th at the bottom. And there are a variety of ways that you can consolidate this. Maybe what we'll just do is say that this right here is the cube root of z, and down here is z to the 4. And we'll keep it this way. And then we're going to raise that to the negative 2, which is going to say flip this and square everything. So on the top here, we're going to have y to the 8th squared, it's y to the 16, and then z to the 4th squared is going to be z to the 8. And then on the bottom, we'll have 3 squared, so it's our only number in there. That's going to be 9. And then x to the 4th, that's going to be x to the 8. And then z cubed, we're going to call that cube root of z squared. And you'll notice that I didn't really combine this z and this z. And just hold off for a minute on why that's true. We'll cover that when we talk about top-heavy exponent fractions in just a moment. But just to wrap up here with this large exponent cluster fraction, so this isn't really a new rule. All that's going on here is I'm combining all the exponent rules into this big cluster fraction. And that's really what they're testing on the ACT, where you often see this is, can you just do all these rules together really quickly? Moving on to our next rule here, we have the change of base or common base exponent questions. So they're asking for me to solve for x here, but we don't really know how to extricate x out of all of these exponents. And the way that we want to do this is find a common base. So if you had something, for example, like 3 to the x equals 3 to the 2, then it's pretty clear that x is equal to 2. But in this case, it's going to be hard to compare 3x over to this because 4 and 32 aren't really the same number. So in this case, our common base for 4 and 32 is actually going to be 2. So this is 2 to 2. And 32 is 2, 4, 8, 16, 32. So that's 2 to the 5. To the 10, sorry. Squared. And then we can take power to power, multiply, and then we're going to have 2 to the 2 to the 3x is going to equal 2 to the 6x, and 2 to the 5 to the 2 is going to give us 2 to the 10. And now since the bases are the same, we can go ahead and drop them out and have 6x equals 10, which is going to be pretty straightforward to say that x is 10 over 6, or just 5 over 3. Which I suppose you could also call 1 and 2/3 if you were being really excited about mixed fractions. So with these change of base problems, it's usually going to be a pretty familiar base that you're going to find 2, 3, or maybe 4 or 5, probably nothing bigger than 5 for the most part. So just recognize that as you're trying to solve for the exponent variable. Next and finally, we have top-heavy exponent fractions. So as a matter of convention, the SAT and the ACT don't like when you have something like 5 over 2 or 7 over 2 or 7 over 3 as an exponent fraction. For whatever reason, they just don't like this. And so whenever you have a top-heavy exponent fraction in the SAT or ACT, you're going to need to turn that into separating the integers out from the fractional elements, the root elements. So for something like x to the 1.5 times x to the 2.5, what really is going on there is saying this is x to the 3 over 2 times y to the 5 over 2. So same thing there. You may see this as this decimal here. You may see it as a fraction. And the way to work through this is to figure out how many integer values of x you can pull out of these numbers. So we could then express this as x to the 1.5, which is to say x times x to the 1/2. And so what they like about this is we have a whole x over here, and then we have the root x to the right, because power times power means we add. 1 plus 1/2 equals 1.5. And then for the y, we're going to have 2.5 as we've seen. So y to the 2.5, which is to say y squared and y to the 1/2. And the way that they would like for you to write this is kind of interesting. It's going to be alphabetical order, x, y squared, and then whatever's in the root, the x, y will just all go together in the root. So for these top-heavy exponent fractions, make sure you keep all the fractional elements together and then all of the integer values outside of the roots. Why is this? I'm not totally sure. If you ask me, this is a bit messier than even this, but that's what they asked for you to do, so got to get the question right. Okay, as usual, got 2 example problems here. Go ahead and try these and see what you can do. All right, let's take a look. For this first one of the 3, you'll notice this is probably the common base question. And so the way that you'll want to look at this is we're going to say, okay, what's our common base from the cube root of 5 and 125? It's actually going to be the number 5. I suppose you could do the cube root of 5 for both of these, but that may add some unnecessary complexity. The way that we're going to approach this is we're going to rewrite the 5 as the cube root of 5 as 5 to the power of 1/3, which we're raising to the power of v. And then 125, we're going to rewrite as 5 cubed. So 5 cubed raised to 2z. And power to power means we multiply, so this is going to be 5 to the v over 3 equals 5 to the 6z. And since we have the same base, we can now get rid of that base and just call this v over 3 equals 6z. And now they're asking us to isolate z and v, so we divide by v to get 1/3 of 6z over v, and then we divide by 6 to get 1 over 18 equals z over v, which is a. Okay, here's our next one. Take a look and see what you can do. All right, we've got a big, obnoxious exponent cluster fraction, or whatever I called that. Let's go ahead and resolve this thing. Didn't give you any answers, so I just wanted to basically do an exercise in exponent rule application. So, like I said, probably fix all the stuff in there as quickly as possible. So we have 2, and then we have x. So we have x to the negative 5 on the top and x to the negative 6 on the bottom. So this is negative 5 minus negative 6 is going to leave us with 1x on the top. We have y to the 7 and then y to the 8. So that's going to leave us with 1y at the bottom. And z to the negative 2/3 and then z to the 4th. So that's negative 2/3 minus 4. That's going to leave us with z to the effectively negative 4 2/3 z. So I'm going to put that all at the bottom. So that's, we have a z to the 4th, but we also have a z to the 2/3. So let's say that that's 4 2/3 z. Let's keep them separate just for the sake of keeping things conventional. So there's a 2/3 down there. We need to raise this all to negative 3. That's going to mean that we're going to flip this upside down. So it's going to be y z to the 4, z to the 2/3 over 2x, which we're going to cube. And finally, we're going to cube those. So y cubed is going to be y cubed. Z to the 4th to the power of 3 is going to be z to the 12th. And z to the 2/3 to the 3 is going to be, well, effectively the 1/3 and the 3 is going to cancel out. So I'm actually just going to go ahead and add 2 to this number of z. That's going to be z to the 12th times z squared, which is z to the 14. And then on the bottom, we're going to have 2x cubed, which is going to be 8x cubed. So all this actually becomes much smaller, which is pretty nice. So this fractional mess becomes y cubed times z to the 14th over 8 times x cubed. Okay, that's it for this video. Hopefully I was able to round out all of the kinds of exponent questions that you could potentially see on either the SAT or ACT with this video. I'd recommend rewatching the first video and this one in conjunction just to get a complete picture, because beyond the topics here, there's really not much else the test can ask you about with respect to exponents. So whenever you're doing an exponent question, you can expect to be one of these kinds of questions covered. So if you found this material useful, we hope that you will like and share the video and subscribe to Quad Education. If you require any tutoring, please reach out to us. Thank you for watching, and I hope you have a great day.